Today in class, we worked on Unit 7, Lesson 4, Ages and Wages, where we looked at simplifying binomials to represent real-world situations. In the Ready section of today's homework, we're going to be using quadratic functions to complete tables and graphs. First, we will look at how to do this using the Desmos program, and then we'll take a look at using the same function to create a table and graph by hand. When using the Desmos program, we simply need to type in the function into the program and the graph will automatically appear for us. If we click this gear button, the option to convert the function to a table will appear, and when we click on that, we get our table of values. We know that the table of values represent our ordered pairs. So -2, 7 is our first ordered pair right here, -2, 7. Our second ordered pair, -1, 0, -1, 0, and so on. If we want to create the table and graph by hand, we start with the same function and we create a table of values. We can select any x values that we wish. It's helpful to select some starting in the negatives and then working into the positive integers. That way we can determine where our x-intercepts are. We're simply going to take each of our x values and substitute those in place of the x's in the original function. You can see how we did that here. We substituted this x with a -2 and this x with a -2, and when we simplify using order of operations, we get the value of 7. So when x is -2, y is 7. Doing that again, for the x value of -1, if we substitute that in for each of our x values in the original function, we find that our y value is 0 when x is -1. And one more example, using our input of 0, when we replace our x's with the value 0 from our original function, we find that the value of y is -5. Using our x and y values that we've just found, we then have our ordered pairs and we can graph our quadratic function. In the set portion of today's homework, we are multiplying polynomials, specifically to linear binomials. In this case, we have one binomial that is squared. We know if we write that out in expanded form, that would be x minus 6 times x minus 6. We're going to be using the distributive property and taking the first term in our first set of parentheses and distributing that to each of the terms in our second set of parentheses. X times x gives us x squared. X times -6 gives us -6x. Then we'll take our second term in the first set of parentheses and distribute it to each of the terms in the second set of parentheses. -6 times x gives us -6x, and -6 times -6 gives us positive 36. We will combine our like terms of -6x and -6x to give us -12x, bring down the other two terms, and we have our product. In the Go section, we are solving systems of equations by substitution. Remember to do this. We are taking the value of one of our variables and we're substituting that value into the other equation in place of that variable. In this example, one of our equations was already solved for the variable y. So this makes it a little bit easier for us. If we were starting with two equations and neither of them had a variable that was already isolated, we would need to do that first. In this case, we know that the value of y is 7x plus 10. So if we take that value, 7x plus 10, and we substitute it into the second equation where our variable y is, then we can simplify and find the solution for x. You can see here how we replaced the variable y with its value, 7x plus 10. Now we'll use the distributive property. 2 times 7x gives us 14x. 2 times 10 gives us 20. And we bring the rest of our equation down. Now we will be combining like terms so that we can simplify our equation. 14x plus 3x gives us 17x, and we bring the other terms down. Now we will use our properties of equality, and we will be subtracting 20 from both sides of our equation, which will leave us with 17x minus 17. Again, using the properties of equality, we're going to divide both sides by 17, and that gives us the value of x, which is the first part, or the x value of our solution to this system of equations. Remember, the solution to a system of equations is the point where the two equations are equivalent. So on a graph, that would be the point where the two lines intersect. We know that they will have the same x and y value at that point. So just solving for the x value is not giving us the entire solution here. We still need to figure out what our y value will be. In order to do that, we will substitute our x value back into our equation and solve for y. So we take this original equation, y equals 7x plus 10, and now that we know what our x value is, it's -1, we can substitute that back in. Using the distributive property, we can multiply 7 times -1 to give us -7, bring the positive 10 down, add those together, and we get +3. Now we have our entire solution, but we want to be sure that that's the correct solution, so we're going to check our work. We do that by substituting our x and our y value back in place of the x and the y in both of the equations. So we want to do it for each one. When we look at the first equation, y equals 7x plus 10, we found that our x value was -1. We're going to substitute the x with a -1, and we found that our y value was +3. We will substitute our y with a +3. We will simplify. We'll multiply 7 times -1 to give us -7. -7 plus 10 is 3. 3 does equal 3, so our solution of -1, 3 works for the first equation. Now we'll check our second equation. Again, we're going to substitute our values for x and y in our solution back into the equation where we see our x and y variables. When we do that and simplify, we see that 3 does equal 3, and -1, 3, our solution to our system, works for both of the equations, so we know that our solution is correct.